सर गुड इवनिंग।
गुड इवनिंग सर।
आवाज आ रही है सर आपको मेरी बिल्कुल क्लियर?
जी जी सर।
अच्छा अच्छा ठीक है। अभी हम लोग स्टार्ट करेंगे सर 7 o'clock पे।
ठीक है ठीक है।
गुड इवनिंग विजय सर।
गुड इवनिंग मैम।
A very good evening, Honorable Director, sir. Honorable Director, sir, am I audible?
Yes, Dr. Khadim, yes, I can hear you. Earlier, it was muted.
Okay, sir. Thank you, sir. Sir, just
Please kindly
sir.
go ahead, please.
Okay, thank you so much, sir. Within 1 minute, we are. It is 6:59. Just.
Fine.
Yes.
Yes, now it is 7 p.m. Now it is over to you, anchor, please.
Priyanka, over to you. Priyanka, please start the session.
Hello. Hello.
Yes, you are audible, Priyanka Singh. Yes, please start.
Yes. Good evening, Honorable Group Director, Professor Dr. Bhavish Kumar Chauhan, sir, respected HOD EN and EE Dr. Khadim Moin Siddiqui, sir, our respected guest speaker, Engineer Vijay Tiwari, sir, all faculty members and the attendees. I, Priyanka Singh of IEEE Student Branch of SRMCEM Lucknow, welcome you all on day 5 of IEEE 20, celebration. Sir, it's a great pleasure to have you here. I would like to share with you all few of his achievements. He is an assistant professor in electrical department of REC Kannauj and currently pursuing PhD from AKTU. He has done MTech in Power Electronics, Electrical Machine and Drives from IIT Delhi in 2014. I feel gleeful to inform you all that he has completed his BTech in Electrical and Electronics from our college, SRMCEM, in 2006. And also, he was awarded with Sri Ram Saroop Memorial Award for college merit holders in BTech first and fourth year. Apart from this, was also awarded with Srimati Nirmala Agarwal Memorial Award for college merit holders in BTech third year. He was also been an ex-faculty at our college SRM CEM. He served as an assistant professor in MIT's Gwalior and has more than 15 years of teaching experience. His areas of interest lies in power electronics, DC to DC converter, soft switching converters, controller designing for converters, multi-level inverters. Thank you. That's all from my side. A brief intro for our honorable guest.
Okay, Priyanka. Before proceeding to speaker, we have our honorable group director, our mentor. So we are moving further under the enormous guidance and motivation from our honorable group director, sir. So now I would like to invite our honorable group director, sir, for welcome address. Sir, please, it is over to you.
Thank you, Dr. Khadim Moin Siddiqui. Dr. Khadim Moin Siddiqui, who is the advisor and the mentor of this branch. Obviously, UP Section Best Advisor Award was given to him, and he has had different decorations and awards in past also, and also a guest editor of an SCI Index Journal. It's honor to have you, and more so, in fact, when you are organizing such a function. So I really congratulate Dr. Khadim and Dr. Indu Prabha ma'am, who is the branch counselor as well as office bearer, anchor of this program, Miss Priyanka, and other IEEE, I would say stalwarts or obvious office bearers who are doing so well. It's an honor and privilege to welcome Dr. Vijay Tiwari ji, and more so because he is really partaking in such kind of activities where you can help others to elevate themselves in terms of awareness level, in terms of domain knowledge. So it's really, we are really proud of your achievement, the way you are doing well, Dr. Tiwari, and you have been outstanding right from your college days, and the values that you have imbibed from your parents and from the ecosystem and your this college itself, that speaks for itself, because you are participating in such kind of events where you can hone the skills of your juniors. Okay, so that becomes that gives us a sense of pride. So it's really privilege and honor to welcome you, and I'm sure this session will be quite beneficial, and I hope this session is being recorded so that in the archive it can keep inspiring other students also. So congratulations to the all IEEE branch, because the way you are doing it, that is why you were given best emerging branch of the UP section. So kudos to you, congratulations to you once again for adding this feeders. And this program is going on, and I know tomorrow also you must be having some function. And throughout the week you have done made us proud, and I'm sure in time to come host bigger and bigger functions. So congratulations. Over to the anchor.
Thank you so much, sir, for your kind words.
Now, I would like to invite our honorable speaker for the expert lecture. Sir, Vijay sir, it is over to you, please.
Thank you, sir. So a very good evening to all of you. Director, sir, Mr. Bhavesh Chauhan, and HOD Electrical, Sandhya ma'am. So I think SRMCM is doing a tremendous good work by organizing such webinars. So it is a very good initiative from SRMCM. Actually, I was the faculty from I think 2006 to 2012, and now SRMCM is I think after joining Dr. Bhavesh sir, it is changing a lot. So many activities, so many involvement, and I heard the NBA visit was also there in your college. So I will congratulate to Director BK Chauhan sir for his motivation and guidance to SRMCM family. So I would like to today this lecture for basics of power electronics and some recent advancement in power electronics. Can I start, sir?
Please, Dr. Tiwari, it's an honor to listen to you.
Okay, sir. Thank you.
And I also congratulate Dr. Sandhya Srivastava for going ahead and doing well.
Yes, yes, sir.
Forgot to mention.
Okay. So I will start this power electronics lecture. The topic is advancement in power electronics. Before starting, I would like to give a small introduction about power electronics and how this power electronics field is affecting the whole world. And this application of power electronics we can find everywhere in this world, and every, I think, electrical engineer is must be aware of this. That is what is going on in area of power electronics. So this is a branch of electrical engineering, and it is the study of switching electronic circuit in order to control the flow of electrical energy. Power electronics is the technology behind switching power supply, power converter, power inverters, motor drives, and motor soft inverters. So basically, power electronics is the technology that acts as an interface between the electrical source and the electrical load, because we have a lot of source and we have to transfer the power from source to load, and so it is a kind of a medium which works between the source to load and the electrical source, which is the power supply available, and the load is the appliance that need the power to be utilized. So this technology ensures that power is taken from source to the load in most efficient and robust way. So you can say this power electronics is basically the controlling of power from source to load end in an efficient manner. So this we can take an example of the basic of power electronics. A typical example in every household is the battery charger for mobile phones. Here the input is AC. We have first converted AC to DC voltage and then regulate to a lower DC voltage in order to charge the battery. So all the conversion process is done by the battery charger, which comprises of power electronic circuit. So this is the one basic example of how much a role of power electronics play in our daily life. Variable speed drive for motor and even regulator for domestic fan are example of power electronic device. Why I have taken this basic example of power electronics? Because every person is nowadays having mobile and they are charging their phone from morning to evening so many times. So this is the basic appliance which we are all are using in our daily life, in which basically what we are doing, we are converting AC to DC and then we are charging our phone. So this is the best example of power electronics in our daily life. So this power electronics is a branch of electronics which deals with the application of solid state electronics for controlling and conversion of electrical power. We have to control the electric power. So to control this electric power, we have to use some solid state electronics devices. What are the devices? We will discuss later. So basically, this power electronics is a combination of, you can say, three branches of engineering. What is power, electronics, and control? Power, we all know that in power system, it deals with the static and rotating power equipments for generation, transmission, and utilization of electrical energy. Then we have electronics. It deals with the solid state devices, circuit for signal processing to meet the desired control objectives. And then control system, which deals with the steady state and dynamic characteristic of the closed system. So before you can say going in the advancement area of power electronics, we should understand the basic concept of power system, electronics, and control theory, because we have to apply these theories to make a viable product of power electronics. So this power electronic system, a closed system, we can say, this is a in which power input we have, we will give this power input to the power converter. This power converter may be of different type, and this once this power converter will convert the power, and the output is we can feed to the load, and from load end we can give a feedback to the controller, and this controller which we are using will control the signals, and the power converter will act accordingly to the feedback, and it will regulate the power, it will control the power. Basically what we are doing in the controller, we are basically controlling the switching pattern of the devices. By switching the different devices at different instant, we can control this power, and we can regulate this power, and we can feed this power to the load. So the components are basically the power converters and controllers. These power converters may be of different type and different like DC-DC converter, AC-DC converter, like that. So I will quote one IEEE paper. We now live in a truly global society in the highly automated industrial front, with economic competitiveness of nations. In future, two technologies will dominate: computer and power electronics. The former providing intelligence as to what to do, and the latter the means to do it. That means the combination of computer and power electronics will change this entire scenario in future. One will provide this computer system, will provide the intelligence to what to do, and this power electronics will provide the means to that how we will do the things, and we can change the society. So modern computer communication and electronic system gets their lifeblood from the power electronics. Every computer system, communication system, and electronic system are based on the power electronics. Without power electronics, these devices will not be work, I think. So solid state electronics brought in the first electronic revolution, where the solid state power electronics brought in the second electronic revolution. So power electronic is basically in mode. Various application of power electronic in motor drives, power supply like both AC and DC, lighting system, high frequency induction heating, electric welding, active filter, bulb power transmission, electric vehicle, and so many applications are there to process power from non-conventional sources. So basically, these are some application of power electronics where we use this power electronics. So in the present scenario, power scenario in the world, conventional sources, I would like to say that uranium will it will finish in 50 years, oil in 100 years, natural gases in 150 years, and coal for 200 years. So what will happen after 200 years or 150 years or 100 years when these conventional sources will be finished? So what we have to do, we have to develop some non-conventional sources, take the energy from the non-conventional sources, so that these conventional sources may be utilized effectively, so that we can fulfill our requirement of power for the future. So in Indian context, I will like to say that total installed capacity, it is the old data, I can say now, not recent data. Installed capacity is 144 912 megawatt, out of which 9%. So maximum energy is from the, you can say, thermal. About 63% is from thermal energy. So only you can say renewable energy about 9% or like that. So we have to utilize most of the renewable energy sources, so that dependency on the renewable sources, dependency on the conventional sources can be reduced, and we can live in a good environment, not in polluted environment. So in India, wind power, small hydropower, and solar power plants, biomass, waste to energy, biomass, gas fire, biopower, so many non-conventional sources are there, and we can use this non-conventional sources. So what are the basically disadvantage of conventional sources, and why we are going for the non-conventional sources? I would like to say that disadvantage, we all know that petroleum gases, when they have inflammable products, and energy sources also release greenhouse gases like carbon dioxide, and they pollute the environment, and they are responsible for this global warming. So every good engineer should discourage these type of practices where we this harm to the society. So I would like to say कि conventional energy, suppose हम एक conventional energy source use कर रहे हैं, तो एक typical example ये है कि अगर हम 100 watt produce कर रहे हैं source end पे, तो load end पे हमारा 17 watt जो है वो पहुंच रहा है. तो आप समझ सकते हैं कि the efficiency is very poor in conventional sources where we should, I say we should discourage this type of thing where the source and converters at the source and the most of the power is getting waste. So actually क्या है कि हमारे पास we are using in conventional sources the turbine. So this turbine and the losses are so much high, and we cannot reduce the losses at the source, and so that's why the conventional sources have a very poor efficiency. So non-conventional sources, most common sources is solar power. We are using the solar power generation system in which we will produce power from the solar panels, and this after that a DC link is there, then inverter DC to AC, and then we can use three-phase line, filter and transformer, and then circuit breaker and utility to the grid side. So this solar power generation is now a very popular kind of generation in India, and the government of India and other states, various states, they are planning to increase the solar power generation. And the second is the wind power generation, especially in coastal areas. This wind power generation is also popular, in which we are converting wind energy, utilizing this wind energy for our power requirement, in which we use this wind turbine and then DFIG, and then converting this wind energy to the electrical energy by using this generator set, and we use grid side converters and source side converters in this. So what I am trying to say is that everywhere we are using this power electronics devices. So advantages and disadvantages of non-conventional energy we have discussed. So what are the advantages? Available in nature, free of cost, inexhaustible, less pollution, less gestation period, and disadvantages that high cost of harnessing the energy, uncertainty of availability, and difficulty in transportation. So these are the disadvantages of non-conventional energy, but taking advantage into the consideration, we'll say that this is the cheapest form of energy, and which will serve for us for over the years. So now this is a typical example of AC drive system, in which we are using this power electronic device. In this a three-phase supply, we use a diode bridge rectifier, which will convert this three-phase power to DC power, and then a PWM inverter, and we will feed this power to the induction motor. And next is application is in power system, in which we use from source end to load end, we are supplying power, and lagging VR demand and other things we can handle with this power electronic devices. I am not going in detail that how this we can calculate, or we can discuss, because we have less time. So another application in HVDC system. Now this HVDC system is also very popular, in which we are using DC transmission to avoid the losses, to avoid the cost. We all know that DC transmission, we have certain advantages of DC transmission over AC transmission. We all know that in AC transmission, higher losses are there. So in order to reduce that losses, we use this HVDC system, where this type of HVDC system is like monopolar link, bipolar, homopolar, multi-terminal, back to back. So this is a recent area in which we use power electronic devices. Basically, we use filters and other devices, converter at the source and receiving end to convert the power. So this is also a very hot topic in power system, HVDC transmission. And in India, the government of India or other states, they have installed this HVDC system also. So these are the monopolar. I am not going in detail, bipolar link and homopolar, multi-terminal, back to back, like that. So these are the component of HVDC system. In HVDC system, what we are using converter, transformer, AC, high pass filter, damp filters, smoothing reactor, and thyristor valves. So these are the power electronics devices, and this running cost of this HVDC system is very less compared to the AC system. So this is the overall scenario of this HVDC system. In India, various this HVDC system has already installed. Lines are there. Projects of HVDC system in India are going in our state, Rihand to Delhi, Vindhyachal, Salur, वाईजैक में है कुछ लाइंस. इस तरह से बहुत सारी लाइनें हैं हमारी HVDC links हैं. And now the interdisciplinary nature of power electronics, will discuss that power electronic and drive system. We should before studying this power electronic and drive system and application, we should know about analog and digital electronics, microcomputers, control theory, power semiconductor devices, converter circuits, electrical machine, VLSI system, computer aided design. Because whenever we are going for any project or doing some projects, we are not limited only for, it is not limited for only electrical engineering, but various subject like analog and digital electronics, microcomputers, उनका यूज होगा. हम कोई भी अगर प्रोजेक्ट बना रहे हैं उसमें, क्योंकि उस केस में हमें कोडिंग भी कहीं करनी पड़ सकती है, कहीं पे हमें जो है कुछ पीसीबी भी डिजाइन करनी पड़ सकती है. सो वी हैव टू नो दिस वेरियस सब्जेक्ट्स आल्सो. सो रिसेंट एडवांसेस आर एवोल्यूशन ऑफ सेमीकंडक्टर मटेरियल्स. जैसे जैसे सेमीकंडक्टर मटेरियल्स आते जा रहे हैं, सो एडवांसमेंट होती जा रही है. एडवेंट ऑफ पावर सेमीकंडक्टर डिवाइसेस, एडवांसेस in power converter topologies, evolution of high frequency resonant link converters, advances in control hardware and softwares, power integrated circuits, advances in analysis and simulation. Because day by day some evolution is going on, and this entire scenario in power electronics is changing day by day. So it is changing very fast. So in power electronics, basically there are some devices. So we are controlling the devices, and by controlling the devices, we can control the power flow. So devices, we all know the diode, simple device, power electronic device, anode and cathode is there, and we can. ये आप लोग सभी लोग पढ़ चुके हैं. Then the thyristor is the basic power electronics divided invented in 1960s, in which we have anode, cathode, and gate. And by controlling the gate terminal, we can control the current from anode to cathode. Then bipolar junction transistor, BJT, in which base, collector, and emitter is there. By controlling the base, again we can control the current or voltage. Then MOSFETs, metal oxide semiconductor field effect transistor, in which drain, source, and gate is just like this BJT. Some differences is there, like gate is insulated from the source, though यहाँ पे जो है the input impedance is very high. So by controlling the gate, we can control the current from drain to source. So metal oxide MOSFETs are very, very popular in DC-DC converters. So another device like GTO, gate turn off thyristor, by using a pulse on gate, we can turn off the thyristor. So it is also a kind of power electronic device which is used in various applications. then IGBT. So this IGBT is known as insulated gain bipolar transistor. It uses both the property of BJT and MOSFET. So its input impedance is very high and the switching losses are low. So IGBT is also a popular device in power electronics. So this is a graph of power versus frequency of various devices. Like MOSFET, this frequency is very high, but power handling capacity is low, and SCR, the frequency is low and the power is more. Whereas this IGBT and GTOs, these are the middle level devices in which the power handling capacity is somewhat low than the SCR, but the switching frequency is more. So at MOSFET, you can say the switching frequency is very high and the power is power handling capacity is low. So this MOSFET are basically used in DC-DC converters. So comparison, this is the comparison of BJT, MOSFET and IGBT because we're using most of power electronics circuit. We use most, these devices, BJT, MOSFET and IGBT. So the BJT, I will say, this is a medium, in this we use medium switching frequency devices there, and advantage is simple low on state voltage drop. And MOSFET, it is a higher switching device, low switching losses, facility parallel operation we can do, and low gate losses there. In IGBT, low on state voltage and little gate power requirement. And the CoolMOS, low gate drive requirement, low on state voltage drops. So application of these devices or power electronic devices in residential, commercial, and industrial. In residential, cooking, lighting, and lighting, air conditioning, space heating, freezers, refrigerator, electronics. Commercial, like heating, lighting, central refrigeration, computer, office equipments, UPS. And industrial application like pumps, compressor, blower, fans, machine tools. These are the applications of power electronic device. And again, in transportation, utility system, aerospace and telecommunication, transportation, traction control, battery charger, electric locomotives, utility system, HVDC, static bar compensator, aerospace technology, maybe use karte in aircraft, space shuttle, and telecommunication like battery charges and power supply. So now I will start this evaluation of semiconductor materials. So type of this material are silicon, and then gallium arsenide, silicon carbide, and gallium nitride, and then diamond. These are the materials, semiconductor materials. And this is the overall comparison between general properties of various devices, that silicon, gallium arsenide, silicon carbide, gallium nitride, and diamond. So from this comparison, we can say that the band gap is minimum in silicon and maximum in diamond, relative dielectric constant, peak saturated drift velocity, electron mobility, maximum operating temperature. So depending upon your requirement, one can select this power electronics device and the material used in the power electronic devices. The future trends will be like silicon is used widely because it can be grown in single crystal from large diameter and greatest purity, but will replaced by better semiconductor material in future. Gallium arsenide has larger energy gap, larger carrier mobility, and larger breakdown electrical field strength, and then silicon. The largest crystal wafer size is too small, only 3 inches in diameter. So SCR will be limited to bulk power control at normal frequency and HVDC transmission. TRAG will be limited to only small AC power control at normal frequency. BJT will be replaced by power MOSFET as MOSFET technology advances. So, and power MOSFET will continue for high frequency, small and medium power application. CoolMOS is an efficient new technology for high voltage MOSFET. GTO will replace SCR as technology advances. So as technology advances in future, so this some devices will take over to the other devices. IGBT will continue for medium power and medium frequency application. SIT will limited to high frequency and low power application. AM FM transmitter. SITH will be used limited to high frequency medium power application. And IGCT has better characteristic than G2 and may replace G2 as technology advances. So power converter incorporate a matrix of power switching device and help us to convert and control the electric power. So characteristic of power converters, I will say this is the characteristic of power converter. What are power converters? So converters characteristic that converter fix input supply to the desired output supply. एक fixed input supply को एक desired output supply में it can change. Uses power semiconductor devices which operate as a high frequency switching device and acts as a power amplifier, that is low gate signal control the high output voltage and current. So power converter की basically property है, characteristic है कि it acts as a power amplifier. Power को amplify करने के लिए by low gate signal. एक low gate signal हम use करके एक high output voltage current को control कर सकते हैं. This is the characteristic of power converter topology. So classification of this power converters: diode rectifier, that means AC to DC converter, then AC to AC converter. AC to DC converter को हम diode rectifier बोलते हैं और ये fix AC input को fix DC voltage में change करता है. In control converters, it can fix AC input to the variable DC voltage and then AC to AC voltage controller of cyclo converter. This is the it will basically convert fixed input to the variable AC at constant frequency or fixed AC input to variable AC output voltage at variable frequency. Is that a DC to DC converter? This is also known as choppers, switching regulators, and it will fix DC input to variable DC output voltage. DC to AC, इसको हम inverter बोलते हैं. It will convert fixed DC input to variable frequency, variable AC output. And DC to DC में एक और application है resonant converters. So it will convert fixed DC input to variable DC or AC voltage and variable frequency output. So these are the example of some converters like single phase full converters, single phase half converters, three phase half converters, three phase full converters. So various combination of half converters, single phase and full converters. So this is a three phase AC voltage controller, three phase AC cyclo converters. I'm not going in detail. Cyclo converters basically directly converts AC signal of one frequency to AC signal of variable frequency. These variable frequency AC signal can then be used to directly control the speed of motors. Thyristor based cyclo converter are typically used in low speed, high power application for driving induction and wound field synchronous motors. So classification of cyclo converters, single phase and three phase. Then again, we can classify single phase converter into single to single phase converter and single to three phase converter. Similarly, three phase cyclo converters, we can classify three phase to three phase cyclo converter and three phase to single phase cyclo converter. So these are some application of this cyclo converter: speed control of AC traction motor and cyclo converter for ice breakers propulsors applications. Then inverters, single phase bridge inverters, single phase, three phase bridge inverters. Now some advanced controlling techniques are there, how we can control this gating signals. So in order to control the power flow from source load, we have to switch the device, and for switching the device we can use different modulation technique like pulse width modulation control, in which PWM control is used in AC-DC control rectifier, voltage source, current source inverters to control output voltage and to reduce harmonic and to satisfy the constant voltage and frequency control requirement. In this control, power devices switch on and switch off several times in each half cycle of inverter voltage or current waveform. Basically, हमें जब भी control करना है किसी device को, so we have to give the switching switch pattern. We have to decide the switching pattern. So this PWM technique is the popular technique, and this prominent control techniques are multiple PWM techniques, sinusoidal PWM, or modified sinusoidal PWM, trapezoidal, delta modulation, space vector modulation. These are the various control techniques to control the switching pattern. So desirable characteristic of a power system which we are using, it must be isolation between source to load. This is the most desirable property or characteristic of a power system, that power supply, and that isolation should be there between source to load, high power density for reduced size and weight, high conversion efficiency, low total harmonic distortion in input and output waveform, and high input supply power factor. Then SMPS, we all know switch mode DC power supply known as SMPS, and SMPS has high efficiency and can supply a high load current at a low voltage. The heart of SMPS is any one of the following DC converter. कोई भी हम converter SMPS पे use कर सकते हैं, flyback, forward, push pull, half bridge, full bridge. So these are the heart of this SMPS system. This is some diagram of switching mode, regulator, flyback converter, forward converter. One can go in detail with that. Then AC power supply. So AC power supply are commonly used standby sources for critical loads, and in application where normal AC power supply is not available, the standby power supply is also known as UPS, uninterruptible power supply. So there are two types of UPS, offline and online UPS. In offline UPS, load normally connected to AC main supply, and in online, load normally connected to inverters. So types of AC supply, power supply, switched mode AC power supply, resonant AC power supply, bidirection power supply. These are the diagram of load online and offline UPS, uninterruptible power supply UPS. Then one recent advancement in inverter section is multi-level inverters. So it used to produce high voltage and high power output with low harmonics. Harmonics reduce karna is most important in power electronics by increasing the number of voltage level in the inverters without increasing higher rating or individual devices. So use of transformer or series connected synchronized switching device is eliminated. So use for reactive power compensation in power system. So type is diode clamp multi-level inverter, flying capacitor multi-level inverter, cascaded multi-level inverter, various type of multi-level inverter are there. So recent trends in power electronics is in power semiconductor devices, the control electronics are creating tremendous impact on power converter technology in terms of size, cost, reliability, and performance. Controlled converter are expected to be gradually replaced by the PWM converters. And PWM converter will be used for harmonic filtering and VAR compensation problem, and force commutated voltage fed inverters using thyristor are obsolete nowadays. Then evolution of high frequency link resonant converters. Resonant converters, we use very high switching frequency, and we use LC L and C combination like a resonant tank, in which we can produce a soft switching. By using soft switching, we can reduce the switching losses. So resonant converters use LC resonating circuit, which operates at or near resonating frequency and generate almost sinusoidal current or voltage waveform. The maximum resonant frequency is limited by the turn-off time of power semiconductor device. So these are the classification of resonant converters. series resonant converter, parallel resonant converter, class C resonant converter, and various type of resonant converters like single phase series inverter, single phase parallel inverters. Now, DC to DC converter and multi-input converter. So what are the multi-input converters? We can say that if suppose in any DC to DC converter we have one source. अगर आपके पास एक ही source है and suppose there is a supply failure. So अगर supply fail हो जाती है, in case if your supply fails, then there will be no power transmission from source to load end. तो अगर हम कहीं दूसरा source add कर पाएं, if we can add the second source also, then the reliability of the system will increase. So this is the basic purpose of multi-input converters, that we use more than one source at a time to maintain the continuity of the supply from source to load end. In case suppose there is a failure of one source, then the second source will handle the power. So multi-input converter are also nowadays very popular. In this converter, one source may be conventional, one may be non-conventional, like that. So these multi-input converters are in the second source may be PV array or fuel cell or some other converter also, some other source. The multi-input DC-DC converter is good alternative for drawing power from many DC sources feeding to a common DC bus. हम एक से ज़्यादा sources से power को derive कर सकते हैं and we can feed that power to a common DC bus. So this is what basic multi-input converter is. So I will explain how we can generate a multi-input topology. Suppose we are having a boost or a SEPIC converter. Suppose one SEPIC converter is there and we want to generate a multi-input topology. So suppose we are adding a boost converter with the SEPIC converter. एक boost converter लिया और एक SEPIC converter, दोनों को combine कर दिया आपने. So it will make a multi-input configuration like this. One source from SEPIC, one from boost, and it will feed power to a common DC load. So this is known as boost SEPIC topology. इस तरह we can use buck SEPIC topology or SEPIC topology. So various combinations are possible in multi-input converters, and in multi-input converter we are not it is not limited to only two sources. We can use 3 sources, 4 sources, like that. So this is the MIC which is generated by one boost and one SEPIC converter. Now, what is hard and soft switching? ये भी एक important concept है in area of power electronics, that what is hard switching, what is soft switching. In hard switching, इसमें क्या होगा कि voltage and current, जब भी voltage आपका decrease हो रहा है, current उसी side पे increase हो रही है, तो what will happen? The product of voltage and current, it will not be zero. So when it will not be zero, V and I, अगर इनमें से कोई quantity zero नहीं है, तो power loss होगा, P is equal to V into I. So अगर हम कोई ऐसी टेक्निक यूज करके कुछ ऐसा करें कि जब भी स्विचिंग हो रही है, जब वोल्टेज जीरो हो जाए तब करंट बढ़े, मतलब कहने का है कि आइदर V और I इनमें से कोई एक क्वांटिटी अगर जीरो हो जाए तो जो पावर होगी वो जीरो हो जाएगी. सो दिस इज व्हाट द सॉफ्ट स्विचिंग इज, कि उसमें हम क्या करते हैं, कुछ कोई ऐसा कॉम्बिनेशन हम यूज करते हैं, कुछ ऐसा टेक्निक यूज करते हैं कि करंट और वोल्टेज के बीच में ओवरलैपिंग ना हो. अगर वोल्टेज जीरो हो गया उस टाइम के बाद करंट इंक्रीज होना शुरू हो, तो प्रोडक्ट ऑफ V एंड I वो आपका जीरो होगा. दैट मीन्स कि स्विचिंग लॉसेस आपके रिड्यूस हो जाएंगे. तो जब भी स्विचिंग लॉसेस आपके रिड्यूस होंगे उस टेक्निक को आप बोलते हैं सॉफ्ट स्विचिंग टेक्निक. एंड इन सॉफ्ट स्विचिंग टेक्निक we can use this L and C combination of inductor and capacitor, जिसको हम resonant tank बोलते हैं. So by combination of this L and C, we can use and we can produce a soft switching converter. And the purpose of soft switching converter is to reduce the switching losses. Once the switching losses are getting reduced, the efficiency of the converter will improve. So advantages of the soft switching is reduced switching losses, especially at high switching frequency, and it will increase the power density since the size and weight of the magnetic component is decreased by increasing the operating frequency, and it will reduce the electromagnetic interference also, and it will improve the efficiency. So these are the advantages of soft switching technique. Limitation of soft switching technique is ZCS, zero current switching, zero voltage switching techniques have large voltage and current stresses. In addition, the conduction duty cycle and switch frequency are not individually adjusted, and they require variable frequency control to regulate the output. And in order to overcome these limitations, we are going to zero transition ZVT, ZCT converters, which implement the ZVS and ZCS technique. So in order to overcome these limitations of ZCS and ZVS, another kind of inverter is invented and technique is invented known as ZVT, zero voltage and zero current transition converters. So these are the feature of ZVT soft switching converter: zero current or voltage turn on off for the power switch, low voltage / current stresses of the power switch and rectifier diodes, minimal circulating energy, and constant frequency operation. Soft switching for wide line and load range. तो मैंने आपको बताया कि रेजोनेंट से जो कन्वर्टर्स होते हैं वो कई तरह के हो सकते हैं, ZCS, ZVS. कुछ डायग्राम्स हैं like this. Switches for ZVS resonant converter and ZVS resonant converter में हम यहाँ पे जो switches आपको दिखाई गई हैं, various type of switches, either L type, M type, इनको हम connect कर सकते हैं और connect करने के बाद we can reduce the losses, switching losses. This is the switches for ZCS converters, zero current switching converters के लिए switches हैं. इन switches को connect करने के बाद ही आप जो है एक resonant converter को बना सकते हैं. So the combination of the switches like L type, this is fixed. So by using this switching pattern, we can reduce a ZCS converter. Similarly, resonant DC link converters. In DC link resonant converter, a resonant circuit is connected between the DC supply and the converters. The resonant voltage pulses are produced at the input of the converters, and the converter switches are turned on and off at zero voltage. So advancement of control hardware and software technique. अब बहुत तरह की हार्डवेयर और सॉफ्टवेयर टेक्निक्स भी आती जा रही हैं which we use in power electronics. जैसे VLSI टेक्निक में भी बहुत सारे चेंजेस आते जा रहे हैं और हार्डवेयर बनाते हैं आप, उसमें भी कई सारी टेक्निक आप यूज करते चले जा रहे हैं. सो इस तरह से हार्डवेयर और सॉफ्टवेयर टेक्निक चेंज होती जा रही है, तो उनके आधार पे भी आप जो है वो कन्वर्टर्स को जो है कैसे आप कौन सी टेक्निक यूज करेंगे उसके आधार पे भी आप क्लासिफिकेशन कर सकते हैं. माइक्रो प्रोसेसर और माइक्रो कंट्रोलर का भी एप्लीकेशन यूज हो रहा है. पॉपुलर आईसीज हैं जो हम लोग पढ़ते थे. इंटेल की चिप है ATC51 8 बिट की, ATC 196 माइक्रो कंट्रोलर, हिटाची के हैं, सिमेंस के हैं, टेक्सास इंस्ट्रूमेंट, TMS के हैं. सो these are the popular ICs which we are using in microprocessor and microcontrollers. Advantages जो है इनके significant cost reduction in software, improved system reliability, elimination of drift and EMI problem, design of hardware in universal manner with flexible software to alter with system requirement, information storage, monitoring, diagnostic, and higher control capability, higher performance in real-time control. Actually, we are dealing this power electronics, and we have to design a controller. For controller, we have to use this microprocessor or microcontroller. So there are various type of microcontroller and micro processor which we can use. Then PICs, that power integrated circuit. So recent developments making it possible to combine sustainable power handling and sophisticated function of the same wafer. It is called PICs. So classification of PICs is like high voltage integrated circuits. It combines vertical power device structure with the driver, sensing protection circuits interacting on same wafer, consists of low voltage analog and digital circuit in combination with high voltage lateral power devices. Then smart power ICs are also there. These are the application of power electronic device in which smart ICs we are using. So power source is there and the load is there, and we have to use this power electronic device. So the various type of smart power ICs we can use in power electronics. The system is hanging. Then simulation. हम आते हैं कि what is simulation? So benefits of simulation. As we all know that before going to the hardware, first we do the simulation, and once the simulation result we are satisfied that simulation result is according to our requirement, then we will proceed for the hardware. So the benefits of simulation is assessment of performance, improvement or degradation, evaluating effect of variation in elements such as power semiconductor devices, resistors, transformer, evaluating effects of linear system on the circuit performance, evaluating effort of noise and signal distortion without measuring expensive measuring instruments, optimizing the design of power electronic circuit in terms of circuit parameter and sensitivity analysis. तो सिमुलेशन पैकेज के लिए हमारे पास बहुत सारे सॉफ्टवेयर अवेलेबल हैं, लाइक स्पाइस, मल्टीसिम, मेटालैब एंड so many software piece, CAD power system, computer aided design software, or CASPOC converter, computer aided simulation software for especially for converters. So there are so many softwares are there, and which comes in various packages. So one can proceed with any software. But for I will suggest for a DC to DC converter or simple converters, if you are designing, you can use this PSIM software. It is a very useful software, very easy to understand and very easy to design any power electronic circuit in that. So this is also some software that SEBER is there, PLECS, piecewise linear electronic circuit simulation software. Various software is there, you can download from Google. MATLAB and Simulink, you all know, these are the very powerful mathematical model based equation solvable mathematical software tools. Maximum लोग जो है वो MATLAB और Simulink use करते हैं. इसी तरह से Web Mathematica is also there. It is used for online computational and visualization. So future trends for power electronics will be dominant role in computer-aided design of power electronic system, and dominant role in the development of new PICs and performance improvement of existing PICs. Conclusion, I will say that future R&D effort in power electronics will be principally focused in two directions: new and improved devices, microprocessor, microcontroller based high performance control, and high temperature superconductive materials may be tremendous effect on power electronics technology and application. In future, what will happen that many devices will come, we will use different type of fast processor and controlling techniques, simulation to make this power electronic converters, and that will help the human being. And time, what is the time? Is there limitation for time?
Yes, sir. There is a 40 minutes, but it's okay, sir.
Okay,
Uh,
okay. So, okay, ठीक है, ma'am. So new area will begin the
No, Dr. Tiwari, your last slide is very important. Please complete that slide.
Okay,
It's
okay.
very important.
The new area will begin with commercial use of gallium arsenide, gallium nitride, silicon carbide, and diamond-based power semiconductor devices. So in microelectronics technology advances and its present space, real capacity of power electronics will enhance. The real revolution in power electronics is at dawn and may take place not too distant future. And power electronics will emerge as a mighty electronic engineering discipline. So in future, the devices which now we are using silicon or some other material will change in future, I think, and various new software will come, various computational technique will come, which will help engineer like us to improve the speed and efficiency and so many parameters of the converters. And we will definitely invent new converter, new topologies, and that will help the society and the power engineers, so that in future we can save the energy. Because the purpose of an electrical engineer, that in future, nearby future, we can use this IoT techniques and various techniques, and we can implement that technique in the area of power electronics also. So with this, I will like to conclude that in nearby future, this power electronics branch of engineering will definitely help the electrical engineer, and more researcher and new technology will definitely come in the future. Thank you with this.
Thank you so much, sir.
And I'm sorry that actually the time was the 3 p.m. today, but due to some this administrative work in Kannauj, actually election was going on, so I was not available at that time. So for that, I'm extremely sorry, sir, for that.
No, sir. Don't be.
No problem, sir. But this time you have given us 1 hour, and we are highly delighted. And we have listened your talk, and indeed it was very interesting. So thank you so much for sharing this session. Now, Sandhya ma'am, it is over to you.
Thank you, sir. So I deem it a great honor to propose vote of thanks on the 5th day of IEEE WIE Affinity Group Inauguration Program. So we are going to end this. I would like to express my gratitude to Honorable Engineer Vijay Tiwari, sir. I know, sir, you are very busy today, but still you find time for us and your SRMCEM family. Because I know that SRMCEM की वजह से आपने जल्दी ही उसे accept किया, and a short notice you accept our invitation. Thank you so much, sir, for your knowledgeable webinar on the power electronic and application. Now I would like to extend my gratitude to our honorable director, sir, respected Dr. Bhavesh Kumar Chauhan, and the AD Generic Dr. Indu ma'am, and respect HOD and Dr. Khadiki, sir, for and throughout the five-day event. So thanks, sir. Without you, it cannot be handled. I would like appreciation for the erudite figures for their IEEE student members, WI for their support. Last but not the all my for making this and thank you 1 hour. So thank you so much, everyone. So over to you, Priyanka. Please end this session.
Hello.
Yes, Priyanka, you are audible.
Thank you so much, sir, for lightening us with such a wonderful presentation. It's an honor for us to be part of this. And thank you, ma'am, for giving me this opportunity.
Okay, then everyone can leave this session. Thank you so much.
And now, with the permission of our Honorable Group Director, sir, now we can leave the platform. Thank you all.
Okay, thank you, sir.
Thank you, and congratulations to all.
Thank you so much, sir.
And